Hi guys, Mark Heath here, and we did it. We made it to the final day of Advent of Code, and happy Christmas to you. I'm sure you're watching this well after Christmas, but it's Christmas Day here, and I didn't know if I'd find time to solve today's challenge, but it was a relatively kind one, and so it didn't take me too long. So let's just quickly run through what the challenge involved. So we needed to look up a code from an instruction manual in the style that you used to with old computer games that were copy protected. And the codes are written in rows and columns, and the codes can be calculated, but the first one is at index 1 1, the next one is at index 2 1, and then 1 2, and they kind of go in these diagonal lines. And so you can work out what the code will be at any given row and column if you start here and you work your way through calculating the next code. And the calculation to calculate the next code isn't too hard. We're told what the first code will be. Rather strangely, the first one is 2015 1125. You'd kind of expect 1225, but never mind. And you multiply each number by this, and then you take the remainder modulo this other number, and you can slowly work your way to the correct answer. And in our problem input, we're told which row and column we need to look up. And so the only challenge really is to work out how many elements in the sequence are needed to get to that point. And let's just have a quick look at some C# code that I wrote to solve this. I did at first wonder whether there was a clever trick that you could go directly from the row and column to the number of elements through this sequence you needed to enumerate. But actually I decided to just enumerate through a large number. It really would be handy if C# had an enumerable.infinite rather than just having to pick an arbitrary maximum value. You can't even pass int.maxValue into here, or it will throw an exception. So I've just said up to 10,000, and then I'm using a select many in C# to select the rows and columns. So I'm saying each of these 1 to 10,000 represents a diagonal in the instruction manual, and for each diagonal we're then going to select a range with as many elements as that diagonal. So on diagonal 1 there's only one element, on diagonal 2 there's 2, and so on. And we're using the 2 parameter version of select many, which is just a little bit easier to work with, and for each diagonal and column number we return a set of coordinates whose row is the diagonal minus the column number plus 1, and whose column is the column. Now if that didn't make sense to you, let me just put a quick dump in here using LinkPad's handy dump method to show you what we get to that point. And so you can see the coordinates 1 1, 2 1, 1 2, 3 1, 2 2, 1 3. So the pattern goes 1 2 1, 3 2 1, 4 3 2 1. And in the columns 1 1 2, 1 2 3, 1 2 3 4. And that basically means we can keep going through this sequence until we get to the position we want to. And in LINQ there's this take while method that keeps on taking more elements from the input sequence until a certain condition is met. And the condition here is that we've reached the row and column number that we're trying to get to. Now that actually means that this sequence will end not with this row and column, but just one before it, the preceding element. And so it might seem like we're going to have an off by 1 error and get the code for the previous element in the sequence. But actually, because when we calculate the code for 1 1, we've actually already got that value here. So my sequence is calculating 1 ahead. So actually the off by 1 errors, if you like, cancel out. And by using take while we get exactly the right number of elements in the sequence to calculate the next value for. And so how do we calculate the next value? Well, we can use LINQ's aggregate method here. We can give it a starting value, which is this 2015. We can then, in our aggregating method, our accumulator is just going to multiply the current value of the accumulator, which is the previous code, by this number and mod it by this other number. And we don't care about the actual value of the sequence, which will be the row and column numbers. That doesn't come into it at all. It's entirely based on the previous value. And so when we run that, we get the correct answer. I did have to use longs here not integers. It would have overflowed a 32-bit integer. I actually initially solved this problem with big integers, but actually we don't need to. So there we go, that's the C# solution. Let's have a quick look at an F# solution. And with F#, I was able to take a very similar approach. I've tried to keep this relatively compact, so I create a sequence, and handily we can create a sequence expression with a nested for loop and a yield. So for each diagonal in an infinite series, and F# does have an infinite series, and we're just using the ID function to get a series of incrementing numbers 0, 1, 2, 3 and so on. Then for every column in 1 to that diagonal number, and it doesn't really matter that this sequence starts with 0 because this first one will just not loop at all, we then yield a row and a column number as a tuple. Then we can use take while, which is in F# the same as in C#, where it's not equal to this value. And it does feel a bit of a shame that F# doesn't have a built-in not equal to operator. You kind of have to compose an equal with the not function, which always strikes me as a little bit ugly. Maybe there's a better way, you can tell me in the comments. And then we need to do the equivalent of C#'s aggregate method, and we can do that with the seek.fold function. And again, we just need the current value of the accumulator. We don't need the tuples of row and column positions, and so we just pass in the starting state and the calculation to calculate the next value, and it gets us directly to our answer. And it turned out that there wasn't even a part B to this problem. Once you'd solved part A, you were essentially done. You could just get the final star for free. And so let's head back to the website, and we get this nice animation with presumably Santa and his reindeers traveling across the sky here. And so that brings us to the end of this series of videos. Thanks for watching along. I really appreciate all of you who've watched and commented and given your own suggestions. Do subscribe to my channel. I do plan to make some more videos in the future. I also want to end just with a big thanks to Eric Wastel, who made the Advent of Code challenge. What a fantastic website. It's been loads of fun doing the challenges. I've learned a lot, particularly about F# from attempting these challenges, and also from just looking at the solutions that other people have come up with. There have been all kinds of really interesting solutions on the subreddit. Even today's one, there were some interesting solutions involving recursion that I simply hadn't thought of. Also, if you enjoyed this series, then why not check out my website at markheath.net, where I blog about programming and some audio related programming as well. And also, do check out my Pluralsight courses. I'm an author on Pluralsight. I've got a number of courses here on various aspects of programming, and I do have another one coming up fairly soon, which will be link related. So do watch out for that. Anyway, thanks again for watching, and happy Christmas.